We're in section, so we'll start 2.2. All right, so now they're giving us examples of tangents. I haven't really told you anything about tangent yet. So let me just go to a fresh screen here and just give you the general look of tangent. Here's what tangent generally looks like. Does anybody already know? It basically has vertical asymptote lines at negative pi over 2 and positive pi over 2. Goes through the origin here, and then it kind of looks like y equals x cubed. If you've ever seen that snake graph, it kind of snakes on through like that, and then it just keeps repeating. So, you know, every pi. So this would be, let me see if I can do the right width, about right here. Oops. This is a 3 pi over 2. And then same thing over here. Right in the middle, this is negative 3 pi over 2. Just keeps snaking on through. It's endless snakes. Dot, 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 and dot, dot, dot. Forever to the left, forever to the right. Just a bunch of snakes like that. So that's tangent graph. We could, you know, I could show you by plugging in points and all that. Not going to do it. If you want to see more details about why, come to my office. I'd be glad to, I think that's all interesting. I'd be glad to go through it with you. But in the interest of time, I'll just say, okay, so there's the basic tangent graph. It does the, you know, the snake thing. It goes through the origin at 0, 0. Cotangent is going to be the almost, let's see if I can squeeze cotangent down here. Cotangent, well, maybe let me not go there yet. Let's just stay with tangent. I'm going too fast. So tangent. So there's tangent. So notice the asymptote. These are really important. These are asymptote lines. An asymptote line is a line of approach, right? A guideline for the graph. What that means is this branch goes forever down, forever getting closer to this dotted line, but never touching it, huh? That's what a vertical asymptote line is. It's a line the graph can never cross, but it gets forever closer to it. So this has a bunch of asymptote lines. And the main, you know, we like to focus on just one cycle for all these graphs and then just repeat. So the main one cycle goes between negative pi over 2 and positive pi over 2. That's one cycle of the tangent graph. And he does a snake in between that. Now, they're going to shift it, and I mean, they're not going to go as crazy as they did with sine and cosine, but they're going to do a little bit of shifting, a little bit of twisting. I don't think they're going to do any vertical shifts at all. I'm sure they won't. So that's so know the basic one. You put on your 3x5 card for the exam in 2 weeks. Put on your 3x5 card the basic tangent, and then, you know, so you don't have to memorize that. You can put it right on your card, and then we'll do some shifts and stuff like that. All right, so with that in mind, let's go to the specifics they have. So they have 4 of these for us. Maybe I should make that bigger. I should. Okay, so question number 1 is a good question. It's just, you know, multiple choice, match them up. It's a good way to start. I like this book, how they've done this. So they just say, hey, look, here's 4 of them. They just want you to drag and drop. Basically, on the homework, you'll just drag and drop. Which ones go with which pictures? All right, let's take them one at a time. How about this first one here? What is tangent of x plus pi going to do? What's that going to do to something? Remember, it's ABC. This is A, this is B, this is C. A is 1, B is 1, C is pi. He's in the parentheses. They're not going to give us stuff outside the parentheses on these. So that is C, isn't it? It's in the parentheses. Now, the formulas for phase shift are different, and period, are different for tangent than they are for sine and cosine. So for tangent and also for cotangent, no, just for tangent. Let me try that again. Because part of it's the same, part of it's different. So let's just do tangent. Tangent, his period, the period of tangent, do you know how wide is one cycle for tangent? Look back at the graph here. It goes from negative pi over 2 to positive pi over 2. What is this width This is one period, one cycle. What is if you go from negative half a pi to positive half a pi? How much ground did you cover?
Pi.
A full pi. Because you went back a half a pi and forward half a pi. That's one whole pi, isn't it? Yeah, so the tangent, his period, is pi. But he starts in a funny place, doesn't he? He doesn't start at 0. He's a little tricky. So you see those two key observations. He starts, just the normal, unaltered tangent function, starts not at 0, like sine and cosine did, but at negative pi over 2. Starts one cycle, his normal first cycle, and ends it at positive pi over 2, and his period is pi, not 2 pi. Right? Remember, sine and cosine were 2 pi was their period. Tangent's just pi, and he starts in a funny place, even if there's no phase shifts. Okay, so keeping all that together, what does that mean about our formulas? Well, the normal formula for sine and cosine was 2 pi over b, wasn't it, for the period? So guess what it's going to be for tangent?
Pi over b.
Just pi over b, exactly, because he's pi instead of 2 pi, right? For his total period, so to find his period, it's just pi over b instead of 2 pi over b. Okay, so in our case then, the period for this one, well, let's go. Let me write phase shift formula. The phase shift. Now, this is going to be a little tricky. I'm trying to think of the easiest way. I'm going to go a little different than the book here. Again, the show me an example. They do something different, which you could do. I'm hemming and hawing. I'm not sure which one's going to prove to be an easier way, but I think I'll just give you phase shift, and that'll be easier. I think. You can tell even as I say it. So I think then you're going to have to add that other part, and that can be confusing. Yeah, no, maybe I will go the way the book does. It's super close. I'm not sure which way is easier. I'll know by the time we're done with this chapter, but I don't know now which will be easier for y'all. So there's two good ways to do it. Let me do the book. I'm kind of changing my mind right here. So you know the deal. Tangent goes between negative pi over 2 and positive pi over 2, right? One normal cycle, as we saw in the picture here, right? Between negative pi over 2 and positive pi over 2, the two asymptote lines, right? One normal cycle. Let's use that. This is what the book does. I think it's a pretty good idea. So that means that what's inside the parentheses, which is what? X plus pi. What's inside the parentheses goes between negative pi over 2 and positive pi over 2. We could have done sine and cosine this way, but I like the way we did sine and cosine. It's easier. But let's do this for tangent, cotan, probably secant and cosecant as well. Just say, look, let's just find the left and the right. Let's just find the left and the right. So the left is of a normal tangent is negative pi over 2, and the right is positive pi over 2. That's if this was just x, right? You know what I mean by normal. If somebody just said, hey, tangent x, y equals tangent x, what happens? Well, that x goes between negative pi over 2 and positive pi over 2, right? That's what we saw. On the x-axis, it goes from negative pi over 2 to positive pi over 2. For the two asymptote lines, the one period, one cycle. So, same thing here, except it's not just x this time, is it? It's x plus pi, at least for this first function. So you go ahead and stick the whole x plus pi in there between the negative pi over 2 and the positive pi over 2. You with me so far? Now, let's solve that for x. X is saying, I want to be alone. So you ever solve these three-parters, compound inequalities? How do you solve this thing? What do we do to get x alone? X is saying, I want to be alone. He's got a positive pi with him. So we subtract pi. But whatever we do to one part, we do to all three parts, don't we? We subtract pi from everybody. He's gone there. We just have x in the middle, which was our goal. So far, so good. I'm just going to subtract pi from all three. How are we doing? You guys aren't looking so happy. Is this still fun? Are we still having fun? I'm having fun. I hope you're having fun. All right, subtract pi from all three. Now, we got to work that. And that'll tell us the new left-bound, right-bound thing, where those asymptote dotted lines are. That's what it'll tell us. And then we'll just stick the S snake thing in the middle of those, and we're done, basically. That's That makes sense? Let's find the left bound, right bound. How do we do it? Well, we got to come over here and we got to do something with this. How do you do negative pi over 2 minus pi? And then we'll have to do the right side in a minute also. How do you do that? How do you subtract negative pi over 2 minus pi? Got to get a common denominator, don't we? Right? We got two fraction things. Got to get a common denominator. This one's already over 1. Remember, when you've got a whole number or a whole whatever that is, interacting with the fraction, put it over 1, make it look like a fraction. But you got to make the bottoms the same, which means you got to say, okay, I'm going to multiply top and bottom of this guy by 2, so they'll have the same denominator of 2, right? So then what is that? Negative pi over 2 minus 2 pi over 2. See how that's still just a fancy pi? Right? If I cancel those 2's, that's just pi still. It's just a fancy version now that have common denominators, right? So I can put them together now. Right? Fractions must have common denominators to add, subtract them. So I can do it. How do you put them together? Well, this is minus 1 pi, and minus 2 more pi's is minus 3 pi over 2. That's the left edge. We got the left edge. This is minus 3 pi, if you can read that. Minus 3 pi over 2. Good so far? Are we okay with that? Now I got to do the right edge. So I'm kind of running out of room here. Come up here maybe somewhere. Do the right edge. So right up here. So the right edge is regular pi over 2 minus pi, right? Right here. Regular pi over 2 minus pi. Same thing. Put this over 1. Common denominator. Top and bottom by 2. We get pi over 2 minus 2 pi over 2. And that's what? 1 pi over 2 minus 2 pi over 2 is minus 1 pi over 2. Is that okay? What I did right there? 1 pi minus 2 pi is minus 1 pi all over 2. Keep the common denominator. So that's the right edge. Even though it's negative, it is the right edge of one cycle. So this is the left edge. This is the right edge of one cycle of the snake graph, the tangent. So I just make that my 2 dotted lines and put the snake in the middle. So which one of these 4 graphs go from negative 3 pi over 2 to negative pi over 2? I cannot tell. They're just kind of all a mess because they're squished in. You got to make them bigger. I'm going to go back and make them bigger. But are we all good there so far? Oh, it's going to be, this is tricky. Right, because then it's going to go another, the b is 1, another pi, you know. Yeah. So yeah, okay. So that's tricky. Yeah, this is a little trickier than I thought. All right, so let me keep going with this. So what we've got, let me show you. That's why it's hard to recognize. I'll show you why. So far so good, right? We good. We know that our graph goes. Need a little more room. Our first graph that we're trying to do here, y equals tangent. Bump the little button. X plus pi is going, no, I keep doing that. Don't do that. Is going from negative 3 pi over 2 to negative pi over 2, isn't it? And it's a snake, like that. That's what we just found, right? Left edge, right edge? Left edge, right edge, from negative 3 pi over 2 to negative pi over 2. But remember, it just keeps repeating that. On and on and on and on and on. So where's the next dotted line going to be? Yeah, because remember what the period was? The period, remember, was pi over b. And what's the b? The b is 1. This is a, 1, b, 1. So pi over 1, the period is just pi. So that means you just keep adding pi for another cycle. So if you take negative pi over 2 and you add pi, where's that going to take you? Am I losing you? This is not easy, is it? I didn't realize it Yeah, this is kind of tricky. Yeah, where's it going to go? Well, you got to do this add them up thing yet again. This needs to become comfortable for you. Negative pi over 2 plus pi. Do everybody see why I'm adding pi? Am I losing you? I'm adding pi because that's the period. That's the pi over b. Remember, not 2 pi over b. That was for sine and cosine. Tangent is pi over b. The b is 1 right here. B is 1. There's no number in front of the x, so it's a 1. Pi over b, pi over 1. Pi is the period, which means the width to the next cycle. Every cycle. So, well, how do you find where that is? Well, the right edge will become the new right edge. If you take the right edge of this one and you add pi, take negative pi over 2 and add pi, but this is over 1, top and bottom by 2, same thing. Negative pi over 2 plus 2 pi over 2. Can you read that down there? So negative pi over 2 plus 2 pi over 2. That's really negative 1. Negative 1 pi plus 2 pi is 1 pi over 2. Right? We good there? 2 pi's take away 1 pi is 1 pi over 2. So this is pi over 2. Good? And what does it do in the middle there? I didn't draw it very well. It should probably be scooted over, but yeah, it's kind of bugging me. So maybe I will scoot it over a little bit. Should be like that. Should be a little more symmetric. Anyway, it's going to do a snake. Another snake. Just keeps doing snakes. So there it is. We want to grab the graph that does that. Can you tell which one does that? It's that one, isn't it? See, it's going from negative pi over 2 to positive pi over 2. Can you see it? That's the one. What was confusing is we had this part at first. That's what was confusing me anyway. And I needed to do one more cycle to see it clearly. Is that good? So these aren't simple. This is math and science. It demands hours of your life to master it. It's what it took me. Is that okay? Is that making sense? So we got one. We got one done. That was probably the hardest one. All right. How about this one? Can we just? I think we can do the next one without hardly doing anything. What's this one going to do? What's that negative in the front? It's a negative 1. What's that negative multiplier in the front of sine or cosine or tangent? What does a negative number multiplying in the front of any of those always do? Yeah, it just turns it upside down, doesn't it? Right? So, upside down. So which one of those graphs is upside down? Yeah, this one, huh? Number 4. Is that good? See how that one goes the other way? It's an upside down snake. Instead of, so it's 3. They have 2 of them that are negative. Those dirty dogs. Okay. Yeah, they're being tricky. I didn't notice there's another one negative. So is it 3 or is it 4? They're both upside down. See, both the snakes go upside down. So which one is it?
4.
Yeah, it is 4. Why is it 4? Because there's no shift of any kind. See how it's still doing the negative pi? Come on. Negative pi over 2 to positive pi over 2, the normal bounds that we're used to. That's this one, because there's no shifts of any kind, whereas this other one has a shift going on. Right? The other one has a shift going on. So we can do him then. Right? Go, well, this one's got a shift. He's negative, so he's upside down. Him too. And he's got a shift, so he must be that one, because he's upside down with a shift. Right? We good? And then there's only one left, so we got it. By process of elimination, how my kids love to do math. My Johnny boy, he always works this way. Yeah, so there we go. Upside down like that. So it's only one remaining. So we got it. Is that okay? We could do all those out in detail, but we don't got time for that. We'll move on and try to do something like that. Something else like that. Hey, buddy, you're kind of late to class. You shouldn't just be sneaking in the back. No, I'm just kidding. This is Roberto. Just every now and then, like, point him out. He's there to help you. Let's get as far as we can. Let's get through tangent and cotan, maybe. Let's make that our goal. And then we'll just have secant and cosecant for next time. Yeah. All right, so 1/6 tangent 6x. So how do we graph that thing? You know the deal. Now, for tangent, remember, we're going to do things a little different. The period, let's start with the period, which is pi over b for tangent. Pi over b for tangent. So let's try him. And then also do the left edge, right edge thing. That's the main thing, really. Take the 6x right? And put it between negative pi over 2 and pi over 2. That's the left edge, right edge of one cycle. To solve this, you can just divide through by 6, right? Try to get x alone, got to divide by 6. And how do you divide these guys? We just put a 6 in the bottom, put a 6 in the bottom, it's going to be pi over 12 for both of them. Is that making sense? So when you see this, 3-part kind of thing here, it's called a compound inequality. We don't care about the name. But anyway, x is in and 1 below, so divide by 6, not x. Divide by 6, that'll get x alone. Whatever you do to one part, you got to do to all three. Right? So that means, how do you divide by 6? We just put 6 in the denominator. That's what it means to divide by 6, is to just stick 6 in the denominator. That's a quick, easy way to do that, right? That is the effect of dividing by 6. So then this is pi over 12. This is minus pi over 12, and this is x. So what does that mean? That's the left edge, the right edge of this one cycle tangent function. So yeah, so see, this is working better now. That very first one was a shame. The very first one I did this left-right thing on came out pretty difficult. And I had to add another pi and really fiddle around a lot. That's rare. This is more normal. Boom, there we go. Left edge, right. We can probably grab it right now. Well, no, there's a bunch of pi over 12s, aren't there? Okay. So, all right, they're being a little more tricky than that. Okay, so left edge, right edge. Left edge is negative pi over 12. Right edge is positive pi over 12. Oh, actually, no, that is enough, isn't it? Can you tell which graph? So here, let me just draw it down here. So and then we'll grab. So that means the left edge is negative pi over 12. Excuse me. The right edge is regular pi over 12. He does a snake. Now, is he upside down snake or normal? Normal. There's no negative. This is positive 1/6 in the front, so it's normal. Now, you think, what about that 1/6? Well, that would just stretch it or compress it, which doesn't really do anything as far as we're concerned, because the graph goes up forever and down forever. So it just gets up there faster, or actually this one's slower, 1/6. It doesn't matter. It does nothing effectively. If that was, not much visually different. If that was a negative 1/6 in the front, then it would turn it upside down, wouldn't it? You with me? All we really care about is if that multiplier in the front, for tangent anyway, since tangent goes up forever and down forever. Remember, sine and cosine had a top and a bottom. So finite numbers, right? So we really cared about that multiplier in the front. That would make the top bigger, the bottom smaller, that kind of thing. But tangent goes up forever, down forever. So multipliers in the front don't have a big visual effect. They just make it get up faster for a number bigger than 1. 1/6, a number smaller than 1, will make it go up slower and down slower. But in the end, it doesn't look a lot different. All we care about is if that number in the front is negative multiplier, then that'll flip it. Ours is not flipped. So which one of the graphs looks like that? That's B. It's the only one that looks like that. See, this one's off a little bit. His right edge is not, they put pi over 12 there, but that's not where the dotted line is. So that's not A. See how A's wrong? They have the dotted line somewhere past the pi over 12. Wrong. The dotted line is right at pi over 12. So it's not A. C's upside down. So it's B. Is that good on that? You okay? A little better that time, right? It'll pretty much usually be like that. Just do the left edge, right edge thing. You pretty much got it. That's going to usually be, that first one was pretty hard. But this is more normal for tangent. Okay, stop. Okay, so y equals tangent x plus pi over 5. So do the left edge, right edge. Really, you don't even need the period. The main thing is the left edge, right edge thing. So go ahead and do the left edge, right edge thing. Going to need to do some fraction work for that. All right, so put the x plus pi over 5 in between negative pi over 2 and positive pi over 2. You put that right on your 3x5 card for tangent. Left edge, right edge. So you got to solve for x there. So you're going to need to get a common denominator of 10, huh? So first subtract pi over 5, right? Subtract pi over 5 from all three, and then get a common denominator of 10. Roberto, are there new hours?
Yes, finally it was updated, and so they'll be back here.
Good, good, good. Okay, so they're all there.
Now mostly Tuesday, Wednesdays, and Fridays I'll be working. No Saturdays or Thursdays, I think. Yeah, that's basically the big thing.
Good, good. 3
Longer
days.
hours Wednesdays and Fridays, no hours Saturdays and Thursdays. Right?
Good. So Tuesday, Wednesday, Friday.
Pretty much.
Yeah. And they could come to any of those, but your priority will be whatever group is there.
Yeah.
But they could come to your 103 or your 4B, and if you're not focused on somebody else, then you're willing to help.
Exactly, because I'm still going to be there, right? So if no one's there, you got to help anybody, really. So.
Yes. Yes, I know you've spent hours with my students in the past. Yeah, so he's really helpful. So my students in the past have said so. So yeah, go see him if you're having trouble. We just gave a test back, so it's kind of fresh on my mind too. Good timing that you're here. Yeah, so there's some help for you. Great place just to do your homework right there in the lab. Even if Roberto's not there, it's a good place just to do your homework, because when you're stuck, there's other tutors at least that can help you keep moving in your homework. Computers are there. All right, let's solve this thing. So let's subtract pi over 5 from all three, like that. Okay, and that cancels out. And so now we need to get a common denominator, don't we? So that's going to be 10. So I'll multiply top and bottom by 5 on that one, top and bottom by 2 on that one. Is that okay? So this will become 5 pi over 10 minus 2 pi over 10, which is 3 pi over 10. We good with that? Everybody see what happened there? So I subtracted pi over 5, because that's what, you always do the opposite of whatever's next to x to get x alone. And then top and bottom by 2, made that minus 2 pi over 10. Top and bottom by 5, made that 5 pi over 10. 5 pi over 10 minus 2 pi over 10, 3 pi over 10. That's the right edge. Over here, this guy, top and bottom by 5. Top and bottom by 2. Minus 5 pi over 10 minus 2 pi over 10. That's minus 7 pi over 10. That's going to be the left edge. X is going to go in between those, huh? You okay with that common denominator stuff, all that stuff? I'm glad to help you. It's all that little nitty algebra detail that really is important as you move up the line to pre-calc and calc. So negative 7 pi over 10 to 3 pi over 10. So which graph goes, and is this one, yeah, this one's just right, it's not upside down. There's just a 1, positive 1 in front, so it's just normal. So that means between, what is it? Negative 7 pi over 10 and positive 3 pi over 10. I don't know what the middle of that is. I'll just put a dot somewhere. It does a snake thing, a normal snake thing, low to high, like normal. So which one of those does that? Is it A? A looks good to me, right? Is it A? I think it's A. Right? Let me try. B's upside down. Right, B's upside down, it's not B. C's upside down. A's right side up, but it, well, D looks kind of right too, doesn't it? What's the difference between A and D? They kind of look the same to me. What is it?
A little off to the left from the dotted line. And from the dotted line on the right, it's a little off to the left.
It's not at 3 pi over 10? It looks just like it's at 3 pi over 10, doesn't it? Indeed, do I need to like D is wrong because they didn't put the snake in the middle of the two dotted lines, did they? It's kind of a weird thing to do. So it is A, isn't it? See how the snake is right in the middle of the two dotted lines on that? Remember, it's in the middle. I know, they're thinking, oh, I'll try to fool the students. They're thinking, we'll put it in the middle of the dotted line on the y-axis. Yeah, that's not right. It's in the middle of the two dotted lines, which is what A is doing. It's A. All right, guys, we finished there.